Kia ora, year 12 and 13. This is question 3e from this year's differentiation exam. Got to say, this is one of the most boring questions that I've seen in a while. But the good news is that it's pretty obvious what you have to do. So it's a proof question, so we have to really focus on communicating what we're doing clearly. And we're given a curve with this equation, and we have to prove that the second derivative plus 4 times the first derivative plus 4 times the function is equal to 0. So the best thing to do is to do those derivatives carefully before you start to try and substitute them. So let's start by just writing out the function and having a look at what we're going to use here. Well, we're going to need to use the product rule and the chain rule. So dy by dx is equal to 3x plus 2, the first function, times the derivative of the second function, negative 2e to the negative 2x, plus the second function times the derivative of the first. And we need to differentiate that again and also substitute it later, so it's well worth cleaning that up here to have a look at what we've got. We've got e to the negative 2x times negative 6x minus 4 plus 3, which gives me e to the negative 2x times negative 6x minus 1. Now we need to differentiate this to get the second derivative. So it's the same pattern. It's another chain rule and product rule. So the second derivative is going to be e to the negative 2x times the derivative of the second function times negative 6 plus the second function times the derivative of the first. So cleaning up again, we've got a common factor of e to the negative 2x times negative 6 plus 12x plus 2, which leaves me with e to the negative 2x times negative 4 plus 12x. So we've done the differentiation. Now we need to go back and substitute that into the left-hand side and show that it equals 0. So as usual, I'll start by writing down left-hand side and just state what it is. Now we're going to substitute in. So the second derivative was e to the negative 2x times negative 8 minus 12x. Where are we? No, it wasn't. That's not right. Second derivative was negative 4 plus 12x. I'm getting ahead of myself. So it's negative 4 plus 12x plus 4 times the first derivative, which is this one here. So it's 4 times negative 6x minus 1 times e to the negative 2x plus 4 times the function itself, which is 3x plus 2 e to the negative 2x. Just make sure when you're doing a question like this that you are checking everything's being substituted correctly as you go, or you'll get a little bit annoyed at the end. We're going to collect up, take out the common factor, e to the negative 2x, and start to gather everything up. So negative 4 plus 12x, now I'm going to expand this, minus 24x minus 4, and now this, plus 12x plus 8. Now I wouldn't jump quite to having it be equal to 0 yet. I'm being a little bit paranoid here because I'm in an exam, but I'm going to group similar terms. So we've got all of our constants, negative 4, take away 4 plus 8, plus 12x minus 24x plus 12x, which is equal to e to the negative 2x times, I don't know, this is probably overdoing it now, times 0 plus 0, and that's equal to e to the negative 2x times 0, which is 0 as required.